We're given two vectors and asked to find the angle between the two vectors in radians. So if theta is the angle between the two vectors, and we were trying to find the angle between vector v and w, we would use this formula here to find theta, where cosine theta is equal to the dot product of vector v and w divided by the product of their magnitudes. So in our case, we'd have cosine theta is equal to vector a dotted with vector b divided by the product of their magnitudes. So our denominator would be the magnitude of vector a times the magnitude of vector b. So again, we'll have vector a in component form dotted with vector b in component form divided by the magnitude of vector a, which would be the square root of negative 3 squared plus 4 squared plus 3 squared times the magnitude of vector b, which would be negative 1 squared plus 5 squared plus negative 3 squared. So we have cosine theta is equal to, for the dot product, we'd have negative 3 times negative 1 plus 4 times 5 plus 3 times negative 3. And now for the denominator, we'll have the product of two square roots. So here we'd have negative 3 squared, that's 9, plus 4 squared, that's 16, plus 3 squared is 9, which equals 34. So here we have the square root of 34. And then here we'd have negative 1 squared, that's 1, plus 5 squared, that's 25, plus negative 3 squared, that's 9, which is equal to 35. So the denominator is the square root of 34 times the square root of 35. Simplifying the numerator, we'd have negative 3 times negative 1, that's 3, plus 20, plus negative 9, which is equal to 14. So we have 14 divided by the square root of 34 times the square root of 35, which is equal to the square root of 34 times 35, which is equal to 1,190. So now we know that cosine theta, where again theta is the angle between the two vectors, is equal to 14 divided by the square root of 1,190. So if we solve this for theta by taking the arc cosine or inverse cosine of both sides of the equation, this would give us theta is equal to arc cosine of 14 divided by the square root of 1,190. And now we'll go to the calculator to get a decimal approximation for theta. Let's first make sure we are in radian mode, so we'll press the mode key. Notice how radian is highlighted here in the third row, so we'll go back to the home screen. We'll press second cosine for arc cosine or inverse cosine, and then we have 14 divided by the square root of 1,190, right arrow, close parenthesis, and enter. So notice how theta is approximately 1.1529 radians. But because we are going to check this graphically, let's also convert this to an approximation in degrees. So we'll take the angle in radians and multiply by 180 degrees divided by pi radians. And enter. So in degrees, it would be approximately 66.06 degrees. Again, the question does ask for radians. When we look at the graph of this in 3D, it'll be easier to check to see if the angle is approximately 66 degrees. So let's take a look at these two vectors in space. Here's the graph of the two vectors in space, and notice how the angle between these two vectors does appear to be approximately 66 degrees, verifying that our work is correct. If we pause it here, it's much easier to approximate the angle between these two vectors. I hope you found this helpful.